Okay, welcome again. In this particular tutorial, we are going to be looking at the direct chaining method. In the previous session, we talked about the bucket strategy. Okay, at this point, we are going to be looking at the direct chaining method now. Okay, what is it about this? The thing also follows the previous tutorial where we define a hash function h of x or h of k, which is equal the x modulus 11, okay, where our x equals let me go back to our convention, k1 times 26 to the power 2 plus k2 times 26 to the power 1 plus k3 times 26 to the power 0. Okay, then we find the modulus when we divide it with 11. Okay, now whatever we have as the remainder, call it x. Whatever we have as the remainder, or rather y, is what determines the position where we are going to place this. Now, we noted that when we evaluated LAX, we had 1. When we evaluated DCA, we also had 1. In other words, when we place it here and wanted to place this, we have collision, and so we are looking at how to deal with this collision. Okay, now in this method, instead of reserving the entire sub array for keys that collide, we can instead use linked list, as you can see in this particular figure now. So for each of the location, instead of trying to insert in that indexing location, we create a linked list, a list that is coming from that particular location, and then the very first item that we are going to place in that location is going to be our our first data item. Okay, and then if we evaluate another item and we have the same hashing function, we are also going to create a link from the one that we have already placed in that place, and then we add that. Okay, and that is how we got all this while performing the same hash calculation. Okay, now this particular methodology does not reserve any space that will not be taken up. Okay, but the drawback in this case is that finding a particular item will require you to go through the list. Okay, to go through the list. In other words, if we are to find something like a for DCA, for instance, and we looked at the data hash evaluation, the elemental evaluation, the hash evaluation, we find that it is equals 1. So when we come to this indexing location, we now know that there is a list that is associated with that indexing location, and then we traverse through that list. Okay, now when you are trying to implement a hash table using this direct chaining method, you are going to consider what time it takes to traverse a linked list and what time it takes to traverse an array, and that is what will make you to know whether to go with that alternative or whether not to go with any alternative. Okay, while the other one, the array strategy, that is the bucket strategy, reserve space. It means that if space, for instance, if you are implementing a hash table and you are not bothered about the space is going to take, you can choose to use that particular methodology to implement it. Okay, all right. So but in this one, all of those, there is no need to reserve spaces where you know you will not use it. But the next thing to discover or to think about in this particular one is how much time does it take to traverse through a list. Okay, so what it means that finding a particular item requires a traversal of the entire list. So how long does it take to traverse through a list? How long is a list? All of these things are the things that you are going to consider. Now, if you add another hashing step, it will still give a considerable speed. So in the next approach, we are looking at the open addressing methodology, and we are going to look at the drawback that comes with it and how to overcome the drawback. Okay.